All right, today we're going to talk about building a blueprint for data. Seriously, think about it like this. You would never, ever try to build a skyscraper without a detailed plan, right? Of course not. Well, the exact same thing is true for a powerful database. It is all about the architecture, and we're going to walk through how it's done. I mean, just stop and think about a company like Amazon or Netflix for a second. They are juggling an insane amount of data every single day. Every click you make, every movie you watch, every item you add to your cart. How do they design a system that can track all of that in real time without just collapsing? That's the challenge we're talking about. And here's the secret. They don't just jump in and start coding. No way. That's what separates a professional data structure from, a digital shack. Before anyone writes a single line of code, a detailed plan gets drafted. This blueprint makes sure the final system is strong, it's efficient, and, this is the most important part, it actually solves the problem it's supposed to. It's all about deliberate design.
Okay, so let's back up for just a second and get a core concept down. At its very heart, a database is the engine inside what we call an information system. Its whole job is to take raw, meaningless data, like, say, the number 7, and the text blue widget, and turn it into actual useful information. Like, hey, we sold 7 blue widgets today. The entire point is to give people the insights they need to make smart decisions. That's it. That's the game.
And this right here, this is the why. This is exactly why we need that blueprint. On the left, you've got total data chaos. Just imagine trying to find all the electrical engineers in your company, but in your spreadsheet, their job title is sometimes elect engineer, other times ELDET engineer, and sometimes just EE. It's a total mess, right? Good design creates order. It makes sure every single piece of data has one, and only one, well-defined home. That clarity is everything. So how do we actually get from that chaos on the left to that beautiful order on the right? Well, you follow a master plan. Just like a real architect has a phased plan for a huge construction project, a database designer has a life cycle to guide them all the way from a simple idea to a fully functioning system. And here's something you gotta understand. It's not just one plan. It's actually 2 plans working together. You have the Systems Development Lifecycle, or SDLC. That's the big picture. The plan for the entire app, our whole building complex. But nested inside that, you have the database lifecycle, the DBLC. And that's a specialized plan focused only on the database, the foundation and framework. Because if that foundation is shaky, the whole application is going to come crumbling down. So this DBLC, it lays out a really clear 6-step journey. It all kicks off with the initial study, which is where you figure out your goals. From there, you move into the design phase. That's the blueprinting we're talking about. Then, of course, comes the actual building and testing. But once you go live and enter the operation phase, the work's not over. Just like any building, it needs constant maintenance to stay strong and secure. All right, let's dive into what I think is the most creative part of this whole thing, the conceptual design. This is where the architect sits down with a blank sheet of paper, starts sketching out the big ideas, and turns what the client wants into a visual form for the very first time. Now, the architect can't just draw whatever they want, right? They've got a brief from the client. And in our world, that brief is made up of business rules. A rule could be something like, a customer can have many orders, or every order must be shipped to a valid address. These rules aren't suggestions. For a database designer, they are the absolute source of truth that dictates the entire structure. So when it comes to the actual sketching, there are basically 2 ways to go about it. You can go top-down, where you start by sketching the entire building and then you figure out the rooms inside. Or you can go bottom-up, where you design the perfect kitchen and the perfect office first, and then you figure out how to fit them together into a bigger building. For big, well-understood projects, top-down is usually the way to go. And this brings us to a really core principle of good, efficient design, the minimal data rule. It's so simple. Every single piece of data you decide to store has to have a purpose. Think about it. An architect wouldn't design a room that nobody will ever use. It's a waste of space. Same idea here. We don't create space in our database for data that will never actually be used. Okay, so the big deliverable from this phase, the main sketch, is something called an entity relationship diagram, or ERD for short. The easiest way to think about it is like you're creating a cast of characters for a story. First, you identify the main nouns, or entities, things like customer, product, and order. Then you give them attributes. A customer has a name, a product has a price, and finally, you draw the lines that connect them. A customer, places, and order. It's a map of your data world. You know how a real blueprint has a legend in the corner that tells you what all the little symbols mean? Well, that's exactly what a data dictionary is for our database. It's the companion to our ER diagram. This is where we define what everything means. What does CUST_ID stand for? Is it a number, a text field? The data dictionary is the definitive guide to our entire model, leaving no room for confusion.
Okay, our conceptual sketch is done, the client loves it, now it's time to get technical. We're moving from those high-level ideas into the detailed, formal plans that the construction crew, in our case, the database management system, can actually understand and build from. First up is logical design. This is where we translate our ER diagram into the formal structure of tables and columns. We define the keys that link everything together, and then we do this really crucial step called normalization. All that means is we're hunting down and eliminating redundancy. For example, why type a customer's full address on every single one of their orders? That's crazy. Instead, you store their address just once in a customer table and simply link to it. So much more efficient. After that comes physical design, and this is where the rubber really meets the road. This is like the architect specifying the exact type of concrete and steel to use for the foundation. Here, we decide how the data is physically stored on the disk drives. We create indexes to make searching for information lightning fast, and we build out the security to make sure only the right people can access the data. All right, the blueprint is done. Every detail is mapped out. It's time to start building. And just as important, we need to think about how we're going to protect this incredibly valuable asset once it's built. First things first, we've got to pick our general contractor, the Database Management System, or DBMS. And believe me, this is a massive decision. You have to think about the initial cost, sure, but also the long-term cost to operate it. How is it going to perform when we have 10 times more data? Does it have the security features we need? Getting this choice right is absolutely critical to the success of the whole project. Okay, construction's done, the system is live, it's running beautifully, our digital building is complete. But what happens if there's a disaster? A fire, a flood, a major hardware failure? How do we protect our valuable asset from being wiped out in an instant? The answer is a multi-layered safety plan: backups. A full backup is pretty much what it sounds like: a complete copy of absolutely everything. A differential backup is a little smarter. It only copies the data that's changed since the last full backup. And then you have the transaction log backup, which is like a court stenographer, recording every single change one by one as it happens. When you use all three together, it means you can restore your data right up to the minute before disaster struck. So we've designed the perfect blueprint. We've built a solid, secure structure, and we even have a world-class disaster recovery plan. It really seems like we've thought of everything. But there's one last puzzle to solve. In a really busy system, what happens when two people try to book the last seat on an airplane at the exact same millisecond? That, my friends, is the challenge of concurrency, and it's a fascinating problem we'll have to tackle next time. Thanks for joining this explainer.